Welcome, ladies and gentlemen, for another video with Dyson the Mathematical Freak. So, there are an infinite number of numbers in total. There are categories for each of these numbers. So, let's see all of these categories. So before we start this video, I'm going to tell you one thing. Note, in this video I'll use finite infinity or Fi to represent the largest number in any of these collections. So instead of infinity, which is not actual number but a value which has an endless not number but a symbol with infinite with an endless value, so that's why I'm going to use finite infinity, a number so close to infinity, but still it has a finite value. So today in this video we're going to start with natural numbers. Numbers which are used to count are called natural numbers. Natural numbers are symbolized by the letter n. So n is equal to 1, 2, 3 and so on until finite infinity. So this is just what the numbers are. So next are whole numbers. So the collection of natural numbers along with 0 are called whole numbers. Whole numbers are symbolized by the letter W. So W is equal to 0, 1, 2, 3 and so on until finite infinity Fi. So we already covered 2 in less than a minute. So next are whole numbers. Integers. So the collection of positive and negative integral values along with 0 are called integers. Integers are symbolized by the letter Z for Zahlen, which means to count in the language known as German. Yeah, German. Why Zahlen? I don't know. Why German? I also don't know. But integers are still represented by letter Z and no one can change it. So Z is equal to minus Fi finite infinity until minus finite infinity, plus finite infinity, with every number in the middle having an integral value, a full whole value, no decimals included. So next are rational numbers. Every number which can be represented in a fractional form are called rational numbers. These numbers can be represented by the letter Q, meaning quotient, as all rational numbers are quotient of two integers. So for example, let's take 0.3 recurring, which is equal to 1 by 3. 1 divided by 3, which is a fraction. So therefore 0.3 recurring is a rational number. Next, another example is 2. 2 is equal to 2 by 1. 2 divided by 1 is still 2. So therefore it is the quotient of the numbers in the fraction. So therefore it is a rational number. So Q is equal to negative finite infinity to finite infinity with most numbers which are also decimals, not just integral value numbers. But of course there are a few graphs because there are irrational numbers such as pi or Euler's numbers, such like that. So next are irrational numbers. Numbers which can't be represented in a fractional form are called irrational numbers. These numbers are represented by the letter I for irrational numbers, of course. So a few examples include pi, the golden ratio, square roots of most non-perfect squares, and even Euler's numbers, and there is still a lot more irrational numbers. So next, second to last are real numbers. So every single decimal and integer and even irrational numbers, some anywhere between minus finite infinity and positive finite infinity, are called real numbers. These numbers are represented by the letter R. So R is equal to minus finite infinity to positive finite infinity. Yeah. So that means every single number which actually exists are classified in real numbers. Every single possible number, including the one and only irrational numbers, the integers, the decimals. For example, 1.11 pi, every single number is in the real numbers. But find your complex numbers. But you may ask me, yeah, up to now we just real numbers or every number. So how can there be another category which is much more wider and is not in the irrational numbers? So let's look at this. In the real numbers. So a combination of a real and an imaginary number are called complex numbers. So imaginary numbers are numbers which don't actually exist, such as the square root of negative numbers. Negative numbers don't have square roots. They never existed. Such as -1. Its square root does not exist. Positive numbers can only have square roots. Negative numbers cannot. Therefore, these numbers are a violation of the real numbers' existence. These numbers should not exist. So that's why these numbers can be said as fake numbers. These numbers don't actually have a symbol of sorts except for imaginary numbers which have an I. So for example, there is I, also known as iota, 4i, 4 into I divided by 10, and the root of unity, and so on. So yeah, these are the categories of numbers. So yeah, it's much more complex than what you think on a surface. Yeah, the complex numbers are not as complicated to understand, but if we dive deeper into them, it's much more complex than anything else. Yeah, so this is for today about these numbers, the complex numbers, the rational numbers, the irrational numbers, the real numbers, the whole numbers, the integers, the natural numbers, and even the decimals the decimals. So yeah, this is for today about this stuff, the numbers categories. So bye.